Now the next topic is relative density. So before knowing relative density, let us try to remember what is density first. You know, density is given by mass of the substance divided by volume of the substance. I am writing mass and volume, but I am verbally saying mass of the substance by volume of the substance and density also of the substance. So you see, symbolically one can write density is equal to mass divided by volume. And what is the SI unit of density? SI unit of density is kg per meter cube. Okay, kg m to the power minus 3. And you know that CGS unit of density is gram per centimeter cube. Okay, you can write it as gram per centimeter cube. Alright, and 1 gram per centimeter cube is equal to, and this is the relation also you have proved earlier, that 1 gram per centimeter cube is equal to 1000 kg per meter cube. Alright, so these are the relations and already you have learned in the lower classes. Then is coming what is the relative density of a substance or of a body. Relative density of a substance we define, it is the ratio of density of the body divided by, or ratio of density of the body by density of water at 4 degrees Celsius. Density of water at 4 degrees Celsius. Alright. Now, these are the important points. These already you know. So that's why I am just discussing it faster. So that I can come to the next point. So relative density of a substance. It is the ratio of density of the body by density of water at the 4 degrees Celsius. Now, as you know that density of water, rho W, density of water is 1 gram per centimeter cube. That's why if you consider the density of the body in gram per centimeter cube, then RD of the substance, means numerical value of RD of the substance is equal to the numerical value of density of the body in gram per centimeter cube. Because when it will come here, then RD into 1 is RD only. So you can write RD of a substance is equal to numerical value of the density of the body in gram per centimeter cube. Now, RD, as it is a pure number, it has no ratio, as it is a ratio, so it is a pure number and it has no unit, and density is a scalar quantity. So these are the 2 points I have not written on the board, but verbally I am saying you must note it down in the copy and you must learn it also. Remember also that density is the scalar quantity and RD, as it is a pure ratio, it has no unit. Now you consider this fact that RD, you can write that density of the body by density of water. Alright. So you see, density means mass of the body by volume of the body, and then density of water means mass of water by volume of water. Alright. Now, if you make this, that volume of the body and volume of water, you are making them equal. Alright. Then what will happen? You can cancel volume of the body and volume of water. Why? Because you have made them equal. So you see, when volume of the body and volume of water are equal, then how I can reconstruct the sentence? I can reconstruct the sentence this way: mass of certain volume of the body divided by mass of same volume of water. So here you see same volume of water. Then you see volume cancelled, only mass is there. Mass of certain volume of the body, whatever volume of the body you have taken, same volume of water you have taken. So you see volume is no longer existing here. Is that clear? Now we know that volume of the body becomes equal to the volume of the water when it is the displaced water. Yes or not? So you see, you can write it this way: mass of the body divided by mass of displaced water by the body. Displaced water by the body. Can you write it? Because when the volume of the body and volume of water becomes equal, when you are immersing the body inside water and you are considering the volume of the displaced water, then only these two will become equal. So you see, in place of same volume of water, I can just write it displaced water by the body. Is that clear? Now what I am doing? I am multiplying G with the numerator and with the denominator. Then what is happening? You see, mass into G means the weight of the body. So you are getting weight of the body. Weight of the body means where we generally measure the weight of the body in air. And then you see, it will be what? Mass of displaced water by the body into G means weight of displaced water. Is that clear? So you see, relative density, these are the important relations you are supposed to remember. Relative density, you can either write density of the body by density of water at 4 degrees Celsius. It is within bracket. Then from that one, what we have got? That relative density is weight of the body divided by weight of displaced water. Alright. Now, what is weight of displaced water? So you see, you can write weight of the body means I am writing it weight in air. W in air, weight of the body in air. And weight of displaced water is nothing but upthrust. Can you write? Again, upthrust is equal to what? Upthrust is equal to weight of the body in air minus weight of the body in water. We have written, no, in the last lecture, the last one topic was that I wrote, the important formula I wrote on the whiteboard. One was there that upthrust is equal to weight in air minus weight in liquid. So what is the liquid here? Water. So you can write weight in air by upthrust or weight in air by weight in air minus weight in water. So these two we are getting by applying Archimedes principle. Alright, so you are supposed to remember, I will rewrite it, the important formula for relative density. Okay, applying Archimedes principle, you are supposed to remember. I am summarizing next. So you see, these are the important relation for the relative density. One, supposed to remember for solving the numericals. That relative density, either you can write density of the solid by density of water at 4 degrees Celsius, or you can write applying the Archimedes principle as we did, that weight of the body in air. So W air means whose weight? Weight of the solid body in air divided by weight of displaced water. And then you can write it as weight of the body in air divided by weight of the body in air minus weight of the body in water. And or you can write it as weight in air divided by upthrust. Alright, upthrust of water. Upthrust exerted by whom? Upthrust exerted by water, not any other liquid. Okay, that is another important point you have to remember. That relative density of a substance will be upthrust exerted by water, because when we are considering here density of water at 4 degrees Celsius. So if you consider any other liquid upthrust, that will not work. Relative density is weight of the body in air divided by upthrust exerted by water when the body is immersed within the liquid. Now, how to measure RD of a solid denser than water? Why it is mentioned denser than water? Then only it will be completely immersed within water and insoluble in it. The solid never get dissolved into water. So how to do? First of all, you suspend it. This is the diagram I have drawn. That you suspend it from the physical balance. Remove the scale pan from the left hand side. Then just suspend the solid, and right hand side scale pan, put some weight so that it becomes horizontal. Then find out what is this weight kept on the right hand scale pan. That will give you what is the weight of the body in air. Here you see I am writing W air. It means weight of the body in air, not weight of the air. Remember that. So here you see this weight kept, it will give you the weight of the body in air. Now what you do on a stand, you keep one beaker full of water and immerse the solid into water. Then you will see that this will just bend to the right side. Then you remove some weight. Then it will be balanced again. So when it is balanced again, then find out what is the weight here. That will give you weight kept on the right scale pan. That will give you weight of the body in water. Then we know what is the RD of the solid. It will be weight of the solid in air divided by weight of the solid in air minus weight of the solid in water. So very simple way you can find out what will be the RD of the solid, which is denser than water and insoluble in it. Now how to find out relative density of a solid which is denser than water but soluble in water. So you see, when you will put it inside water to get its weight in water, what will happen? It will just get dissolved within the water. Alright, so that's why in that case what we do, we take, instead of water, we take a liquid whose relative density is known to you. Alright, and then we perform the experiment this way. That first of all, we suspend the solid in air, okay, removing the left scale pan and put some weight on the right scale pan so that it get balanced. Then find out what is W air, means weight of the body in air. Now, you have taken, you see in the last experiment I draw water. Okay, here you have not taken water inside the beaker. You have taken the liquid whose RD, relative density, is known to you, and then you what will happen here also, the liquid will exert the upthrust. Alright, so the weight will decrease here. So you see here you have to decrease the weight kept on the right scale pan and then find out the balancing weight that will give you the weight of the body inside the liquid. Then what will be the formula to measure the RD? It will be weight of the body in air divided by weight of the body in air minus weight of the body inside liquid into RD of the liquid. So utilizing this formula and doing the experiment this way, one can find out what is the relative density of a solid which is denser than water but soluble in water. Now by using Archimedes principle, how you can find out relative density of a liquid. Alright. Now you see, according to our concept of relative density, you can write relative density is equal to density of the liquid divided by density of water. Alright. Now by Archimedes principle, you can say that it should be equal to weight of some volume of the liquid divided by weight of same volume of water. Isn't it? So you see, that's why I have written that RD of a liquid, you can write it as weight of given volume of liquid divided by weight of same volume of water. Alright. Now, how one can make the volume of the liquid and volume of water same? If you take a body and if you immerse the body inside the liquid, it will displace the liquid which is equal to volume of the body. Now, if you immerse the same body in water, then what the body will do? Body again displace water whose volume is equal to volume of the body itself. So what you can write, you see here, it will be weight of the liquid displaced by a body divided by weight of water displaced by the same body. Means suppose you have taken a body, you are first immersing it in water, then it will displace, you will get the weight of the body in water and then you are taking it inside a liquid. So what in both the cases what will happen? Weight of volume of water displaced will be equal to volume of liquid displaced. Alright. That's why it is written that weight of the liquid displaced by a body divided by weight of water displaced by the same body. Now, According to the concept of upthrust and Archimedes principle, what will be the weight of the liquid displaced by a body? It will be weight of the body in air minus weight of the body in liquid. And what will be the weight of the water displaced by the same body? It will be weight of the body in air minus weight of the body in water. Alright. So, by applying this formula, that weight of the body in air minus weight of the body in liquid divided by weight of the body in air minus weight of the body, same body in water, one can find out what is the relative density of a liquid. Now this relative density chapter, although it is a small one, but very important concept wise, and you need to practice all the relations regularly. So I request you, please learn all the relation, all the formula given in this topic, particular topic, relative density, thoroughly, and practice it regularly. Thank you, girls.